High-intensity discharge headlights, or for short, HID, often called xenon headlights, are a type of automotive lighting system that uses an electric arc rather than a heated filament to produce light. Inside the bulb, a mixture of xenon gas and metallic salts is excited by high voltage, creating a bright bluish-white light that is significantly more powerful than traditional halogen bulbs. To put it simply, halogen bulbs work like a campfire, burning a filament to give off light, while HID bulbs are more like capturing a lightning strike inside a glass capsule through arc discharge. The story of HID headlights begins outside the automotive world. They were first developed in the mid-20th century for industrial and street lighting, where efficiency and brightness were highly valued. It was not until 1991 that BMW became the first automaker to bring HIDs to production vehicles in the E32 7 series. Throughout the 1990s and early 2000s, HID headlights became synonymous with luxury as brands like Mercedes-Benz, Audi, and Lexus embraced them. The 2000s also saw a surge in aftermarket HID conversion kits, making the technology more accessible to everyday drivers. However, these kits were often poorly installed and raised significant safety concerns due to glare. Today, HIDs remain in use, particularly in premium vehicles, but the technology is slowly being displaced by LEDs and, more recently, laser headlights. The engineering behind HID headlights makes them fundamentally different from halogens or LEDs. An HID headlight consists of three main components: the bulb, the arc tube, and the ballast. The bulb contains xenon gas and metal halide salts. When high voltage is applied, an electric arc jumps between two electrodes, vaporizing the salts and producing intense light. This process is supported by the ballast, an electronic control unit that provides the initial surge of over 20,000 volts needed to ignite the arc, and then maintains a steady current for stable operation. Xenon gas plays a critical role by helping the arc ignite quickly and reducing warm-up time compared to older discharge lamps. Once stable, the bulb produces light across a range of color temperatures, typically between 4,000 K, warm white, and 6,000 K, cool white blue. However, unlike halogen or LED bulbs that switch on instantly, HID headlights usually take 10 to 30 seconds to reach full brightness. When compared with other headlight technologies, the differences are clear. Halogen bulbs use a heated filament to produce about 1,000 to 1,500 lumens, with a yellowish color temperature around 3,000 K. They are inexpensive but inefficient and have a short lifespan of 500 to 1,000 hours. HID headlights, on the other hand, generate about 3,000 to 3,500 lumens, are more efficient at about 80 lumens per watt, and typically last 2,000 to 3,000 hours. Their color temperature range falls between 4,000 K and 6,000 K, producing the white to blue light often associated with premium cars. LEDs now push the performance envelope further, delivering 3,000 to 4,000 lumens or more, achieving efficiencies over 100 lumens per watt, and lasting up to 30,000 hours. Unlike HIDs, LEDs turn on instantly and require less maintenance, but they remain more expensive than both halogens and HIDs. The benefits of HID headlights are significant. They are up to 3 times brighter than halogens, providing a longer throw and a wider beam spread, which improves visibility of road signs, lane markings, and potential hazards. They are more efficient than halogens, consuming less energy per lumen, and they last 2 to 3 times longer, which reduces replacement frequency. Additionally, their crisp, bluish-white output adds aesthetic appeal, making vehicles look more modern and premium. However, HIDs are not without drawbacks. They require a warm-up period to reach full brightness, which can be inconvenient. If improperly installed, they can create dangerous glare for oncoming drivers, making them controversial in traffic safety discussions. They also come with higher upfront and replacement costs, since the bulbs and ballasts are more expensive than halogens. Ballast can fail as well, adding complexity to maintenance. Finally, regulations limit their use, especially in the aftermarket, where many HID kits do not meet legal standards. Safety is perhaps the most pressing concern with HID headlights. Their intense brightness means that without proper beam patterns, they can blind other drivers. For this reason, HID bulbs must be paired with projector housings specifically designed for them. Many jurisdictions, including the US and Europe, prohibit installing HID kits in halogen reflector housings. To mitigate glare, factory HID systems often include automatic leveling systems and headlight washers. Regulatory compliance is strict. In the United States, the Department of Transportation enforces rules on brightness, beam cutoff, and color, while in Europe, the Economic Commission for Europe, (MOIECE), requires features such as auto-leveling and washers for HID-equipped vehicles. Some countries outright ban aftermarket HID conversions. In real-world use, HID headlights are most commonly found in luxury and premium vehicles, especially models produced between the 1990s and early 2010s. Aftermarket kits became popular among budget-conscious drivers seeking better performance or style, but these often conflicted with safety and legal standards. Today, the primary market for HID products lies in replacements for existing systems, since millions of HID-equipped vehicles are still on the road and require new bulbs or ballasts over their lifetimes. Globally, regulations continue to shape how and where HIDs can be used. In the US, DOT-compliant systems are mandatory, and non-approved aftermarket kits are illegal for road use. In Europe, ECE regulations demand more safety features in HID-equipped cars, including leveling and cleaning systems. Other regions vary, with some countries banning aftermarket kits altogether, while others apply less stringent enforcement. In conclusion, HID headlights represented a revolutionary step forward in automotive lighting when they emerged, offering much greater brightness, efficiency, and lifespan compared to halogen bulbs. However, their inherent drawbacks, warm-up time, glare, cost, and regulatory hurdles, have limited their long-term dominance. With the rapid rise of LED and laser headlights, HID technology is gradually being phased out in new vehicles, though it remains an important and practical solution in the vehicles that still use it. For many drivers, HIDs are still a valuable choice, provided they are properly installed and compliant with regulations. To help address some common questions, HID headlights are not legal everywhere. In many regions, aftermarket HID kits are illegal unless installed in approved projector housings. HIDs last longer than halogen bulbs, but generally have a shorter lifespan compared to LEDs, which can last the life of a vehicle. Installing HIDs in halogen housings is unsafe and usually illegal, as it creates glare. The bluish color sometimes seen in HID headlights is due to higher color temperature ratings, typically around 6000 K, but going higher sacrifices visibility for style. Finally, while HIDs were once the brightest option on the market, modern LEDs now often outperform them in terms of efficiency, durability, and instant-on capability.